Miss Laura, and in this video I'm going to teach you about functions, continuing patterns, and making predictions based on tables and graphs. We discovered in the last video that there's patterns all around us and everything in the world really exists in some sort of a relationship. Now, once you observe a pattern, you can predict the information beyond and between the data observed. So the ability to use patterns to make predictions makes it possible for you to run to the right position to catch a ball or to guess how a story will end. Now, what we're going to look at today is an experiment done by Leaky Leary. So he did this experiment to determine the rate at which a leaking faucet loses water. And he recorded his data in the table below. So here we're measuring time versus water volume. So we're looking at how time changes and how water volume changes. So if we look at time, we're going to notice that it's increasing by 5 each time. So our seconds, as we can tell by what it's being measured by, is increasing by 5. Our water volume, how much water we're ultimately losing, is increasing by 4. So that means that we're losing 4 milliliters for every 5 seconds. So now what we're going to do is we're going to take this experiment and answer some questions and make a graph based on it, and then use the graph to make some predictions. So first question, what variables did Larry investigate in his experiment? So remember, when I talk about variables, I'm talking about the independent and dependent variables. So first of all, let's talk about the independent variable here. Remember, the independent variable is what we control or is what's doing the controlling. In this case, time. And remember, we said that time would be a common variable. It would pop up a lot. And most of the time will be the independent variable, as it is here. So time is our independent variable. Also notice that it is the x variable. It's an x in our table. So we know that the independent variable represents the x variable. Now, the dependent variable, the result of the independent variable, or the outcome of the situation, is in this case the water volume that we've lost. So the water volume would be our dependent variable here. Now again, notice that the water volume, because it's the dependent variable, is the y in this one. So again, dependent variable is representative of the y in an algebraic expression. So we're going to start by graphing the data from this table onto this graph. Now, before we do anything, we're going to label our axes. So remember, the axis on the bottom is the x-axis, and then the axis that goes vertically is the y-axis. Now, we're also going to label them with our independent and dependent variables and number them. So remember, the x-axis, or the independent variable here, is the time, and the y-axis, or the dependent variable, is our water volume. Now I'm going to go ahead and label my time axis by 5, since that's what it counted by in the table. And then I'm going to label my y-axis by 4, since that's what it counted by in the table as well. So now when we graph this, we're just going to plot each point as it is. So remember, the time is the x and the water volume is the y. So when I'm looking at each of these coordinates, I'm dealing with an x and then a y, and then so on, an x and then a y. So the first point we have is 5, 4. So we're going to go over to the 5 and then up to the 4. Okay, then I have 10, 8, then 15, 12, then 20, 16, and you should notice the pattern here on the graph. It's just continuing to go up 1 and then over 1 on my graph. Okay, so this would be the graph of this faucet leaking as time has progressed. Now that we've made our graph and analyzed our table a little bit more, let's make a few predictions now as to how much water we would lose in a given amount of time. So remember, we are losing 4 milliliters of water every 5 seconds, and I got that because my milliliters are changing by 4, meaning I'm losing 4 more. And then my time is changing by 5. So 4 milliliters in 5 seconds. So now I want to know how much water, first of all, would be wasted in 2 minutes. Well, first of all, I know that 1 minute is 60 seconds, right? I could extend my table out to 60 and it wouldn't have to go that far. So here's 55, and then we would go to 60. So that means I'm adding 4 down here. So this would be 44. And then finally 48. So I know that in 1 minute I lose 48, So I would expect that to be double if I'm doubling the number of minutes. So I'm saying 1 minute, I lose 48 milliliters. So in 2 minutes, I would double that. And then I would expect to lose 96 milliliters of water. Again, that's 48 doubled. So this would be my expected answer for 2 minutes. So now what about 2.5 minutes? So again, we've got to convert it. So I know that 2 minutes, I'm going to lose 96 milliliters of water. So 2 minutes, I lose 96. What's a half a minute, first of all? So we need to know that a half a minute, 0.5, is equal to 30 seconds, right? Well, that's on my table right here. So I know that in 30 seconds, I lose 24 milliliters of water. So put it all together, I would add 96 plus 24, and that would give me 120 milliliters of water that I've lost in 2.5 minutes. Okay, let's move it up a little bit more. What about in 3.5 minutes? So 3 minutes, remember 2 minutes, I lost 96 milliliters. Going back to 1 minute, and I've lost 48 milliliters of water. So we would expect it to be 3 times that. So again, if 1 minute I lose 48, in 3 minutes I would expect to lose 3 times that, which would be 144 milliliters of water. And then I'm going to add 15 seconds to that. So again, plus that extra 15 seconds, well, that's here on my table. So I know that in 15 seconds I lost 12 milliliters of water. So if I put that all together, I would have 144 plus 12, which would give me a total of 156 milliliters that I've lost in 3 minutes and 15 seconds. So how do we make our predictions? Well, really, we used our table and we extended our table. So we not only did we use the numbers that were on our table, but we also extended it as well. All right, we're going to take it a little bit further now and look at kind of an equation to help us solve some of the rest of these questions. So remember, we're looking at the rate at which this problem is changing. We've already determined that we are losing 4 milliliters every 5 seconds. That's how our table's increasing. So therefore, I can come up with the equation y equals 4/5, that's 4 milliliters for every 5 seconds, times x, my time. So remember, x is the time in seconds, and y is the water volume that I've lost. So what we're going to do here is we're going to find out how long it would take for a container to overflow if it was looking into a 1 liter measuring container. So first of all, 1 liter, I need to know how many milliliters are that. So milli, first of all, means 1,000. So in 1 liter, there are 1,000 milliliters. So basically what I'm converting to is this 1,000 here. So that's what my milliliters needs to equal. Since my milliliters is the y here, I'm going to take and replace this y variable with 1,000. So I'm going to say 1,000 equals 4/5 times x. And we can solve this one of 2 ways. We can either divide both sides by that 4/5, or we can use our reciprocal. So here, let's multiply both sides by the denominator. That'll cancel that out. So let me multiply 1,000 by 5 as well. That will give me 5,000. And then on the other side, since this cancels out, I'm going to just be left with 4x. So now I have to solve for the x, and I'm going to do that by dividing both sides by that 4 in front of it. So now I have 5,000 divided by 4, which is then going to give me x equals 1,250. Now remember, this is in seconds because that's what my time was measured in. So to convert it, I would need to convert it back to minutes if I really wanted to understand that. So in order to convert it into minutes, I would just divide by 60, since there's 60 seconds in 1 minute. And that would then give me approximately 20 minutes and around, or 20.8 minutes, something like that. So close to 20 or 21 minutes, about. before it would overflow. All right, I'm actually going to skip number 6 for now. I want you to think about what other variables might have an impact over how much water is in that container, and what other things could affect the experiment. And we'll come back to that question in class. So I'm going to go on to number 7. If a faucet leaked at the same rate as Larry's experiment, how much water would be wasted in 1 month? And assume a month has 31 days. So let's figure this one out. So again, using my equation, remember, y equals 4/5 x, because I lose 4 milliliters of water every 5 seconds, where x is time and y is the amount of water that I've lost. I'm going to now find out how much water would be wasted in 1 month. And again, 1 month has 31 days. That's a measure of... All right, I'm going to skip number 6 right now. I want you to think about what other variables might have an impact on the amount of water that's in the container, or how fast the water flows. We'll come back to that question in class and think about what else could impact this situation. Let's look at number 7. So if a faucet leaked at the same rate as Larry's experiment, how much water would be wasted in 1 month? Assume a month has 31 days. So in order to answer this, we're going to use the same equation that we just found out. So remember, we used y equals 4/5, because we lose 4 milliliters of water every 5 seconds, times the x. And remember, x is our time and y is the amount of water that we're losing. So for this question, we're finding out how much water we're going to lose in 1 month. And remember, a month has 31 days, or that's what we're going to say. Remember, this is a measure of time. So this is our x variable here. So I'm actually going to plug it in for that x. Now, the problem is that I didn't measure in days, I measured in seconds. So before I do anything, I'm going to have to convert days down to seconds. So our math is going to get really big really quick here. So let's start with that 31 days. So first of all, to convert days, the next smallest we can go down to hours. So there are 24 hours in 1 day. So that would be 31 times 24, which is going to give me 744 hours in 1 month. All right, so now from hours, we can take it down to minutes. So remember, in 1 hour, there are 60 minutes, so that's 744 times 60, which is going to give me 44,640 minutes in 1 hour. And then from minutes, we can take it down to seconds. And again, there's 60 seconds in 1 minute, so I would multiply by 60, and it gets really big, really quick here. So this is going to be 2,678,400 seconds in 1 month. So this is the number we're looking at here, and this is the number I'm going to take and plug in for that x. So let's rewrite this as y equals 4/5, and then instead of that x, I'm going to write 2,678,400. Now this is just a matter of multiplying 4/5 times 2,678,400, and I can do that in my calculator, and that would give me 2,142,720. And that would be how much water, how many milliliters, I should say, of water that would leak out of that faucet in 1 month. So quite a bit of water I would lose in that 1 month. Now, how do we get to that answer? Obviously, we had to convert our days in down to seconds and then just plug it into our equation. So lots of math for a simple answer, but it still works and it's a little bit faster than trying to figure out a table or a graph. Okay, so let's look at this question now. So it says, due to the shortage of water in our area, the San Antonio water system charges its customers 0.152 cents for every 10 liters of water that is used. So we're going to use this information, our answer from the last questions, to figure out the cost of water wasted by a leaking faucet in 1 month in San Antonio. And remember, we assumed that 1 month has 31 days. So first of all, we just figured out how much water we lose in 1 month. So we lose 142,720 milliliters of water in 1 month. Okay, that's in 1 month. Now, I'm going to have to first convert this down to liters to understand. So in liters, remember I told you that there are 1,000 milliliters in 1 liter. So to figure out how many liters I've actually wasted, I have to divide this number by 1,000. So when I divide this number by 1,000, I'm going to decrease it by quite a bit. I'm left with 2,142.72 liters that are lost in 1 month. So that's a little bit easier of a number to work with. Okay, now, they're not going to charge me for every liter. They're going to charge me for every 10 liters that I use. So now I'm going to group this down to tenths. So I'm going to take this number here, 2142.72, and divide it by every 10 liters that I use. So again, really it's just going to move the decimal. So divided by 10 again is going to give me 214.272 groups of 10 that I use. So this is the number that I need to look at. Now, they're going to charge me $0.152 for every 10 liters that I waste. So I wasted approximately 214.272 groups of 10 liters. So I'm going to take this number now and multiply it by what they charge me, which is 0.152. So this is then going to give me approximately $32.57. So if I left this faucet running and I didn't do anything to stop it, then in 1 month I would be charged $32.57 for leaving that water on. So again, lots of work to find out this answer. We did have to convert milliliters down to liters, and then liters into groups of 10 liters, and then we multiply by how much they're charging us, and it's approximately $32.57. Hopefully that gave you a better understanding of how to use tables and graphs to make predictions among functions. Keep watching the videos to get more information, and remember to ask any questions that you may have in class.